Segment 1. Fundamentals of Creatine and Bioenergetics. Welcome to this module in our series on metabolic enhancement for clinical practice. Today, we're exploring creatine's multifaceted role in human physiology, from energy buffering to cognitive and reproductive health applications. We'll draw on evidence-based insights to inform your approaches in fields like endocrinology, neurology, and sports medicine. Let's begin with the basics. What is creatine, and why does it warrant our attention? Creatine is a naturally occurring compound, synthesized endogenously from amino acids such as arginine, glycine, and methionine, primarily in the liver and kidneys. It's stored predominantly in skeletal muscle, the brain, and gonads as phosphocreatine, acting as a rapid ADP replenisher. Physiologically, ADP powers cellular work but cycles rapidly. Our bodies regenerate an amount equivalent to body weight daily. During high-demand activities, ADP depletes to ADP, creating transient energy shortfalls. Phosphocreatine donates its phosphate to regenerate ADP, sustaining function for seconds to minutes. This buffering is crucial in tissues with fluctuating energy needs, like muscles during sprints or the brain during intense cognition. Consider the etiology. In sedentary states or aging, creatine stores decline, exacerbating fatigue, much like a depleted battery in a high-performance device. Historically, creatine was isolated from meat in the early 19th century, with early 20th century studies revealing higher muscle levels in active versus sedentary animals, up to tenfold in wild species. Human trials from the 1920s showed exercise enhances uptake, embedding creatine in performance science by the 1990s. Recent meta-analyses affirm its safety and efficacy, with over 700 studies supporting benefits without renal harm in healthy populations. Rhetorical pause. How might this historical context influence your screening for nutritional deficiencies in athletic adolescents or geriatric patients with sarcopenia? Segment 2. Dietary sources and dosing optimization. Shifting to practical nutrition. Creatine is sourced almost exclusively from animal products, with red meat providing about 2 grams per pound. Fish and poultry offer less, while plants contain none due to absent synthetic enzymes. Endogenous production yields roughly 1 gram daily, but daily losses necessitate dietary intake for saturation. Vegetarians often exhibit 30% lower stores within months, per epidemiological data, heightening risks in energy-demanding states. Dosing varies by demographics and goals. Maintenance of 3 to 5 grams daily saturates muscles over a month, while loading, 20 grams divided over 5 days, accelerates this. For cognitive enhancement, higher doses, 5 to 20 grams, show promise, particularly in women due to lower baseline synthesis. Body weight and activity influence needs. Obese or sedentary individuals uptake less efficiently, yet benefit brain-wise by bolstering ADP for willpower and craving control. Case of a 35-year-old office worker with obesity presents with chronic fatigue. Differential includes hypothyroidism or insulin resistance. Management start with 5 grams creatine daily alongside resistance training, monitoring body composition via DEXA scans, not scales, as initial hydration gains mimic weight stability. Practical tip: dissolve in warm liquids for better absorption, avoiding bloating from poor solubility. In pediatrics, low doses, half to 1 gram. Augment diet safely, per recent reviews, though defer higher amounts until adolescence unless clinically indicated. Does your practice include creatine screening for vegan teens in sports? Segment 3. Cognitive and sleep applications. Now, cognitive frontiers. The brain, a voracious ADP consumer, uptakes creatine variably, with thalamic regions, key for integration and executive function, showing greatest increases. Studies demonstrate improved performance in sleep-deprived states. A single 20-gram dose reverses deficits, enhancing processing speed via phosphate stabilization. In aging, creatine mitigates decline, per systematic reviews, though evidence is stronger under stress. For sleep debt, creatine reduces needed hours slightly in women across cycles, aiding recovery, like a surge protector for neural circuits during overload. Interdisciplinary note. In neurology, post-concussion protocols might incorporate creatine for bioenergetic support. However, high evening doses may provoke rumination in high achievers, disrupting sleep. Advise morning intake. Segment 4. Safety, hormones, and reproductive insights. Safety profile. Meta-analyses confirm no kidney impact, even in disease states at recommended doses. Elevated creatinine reflects turnover, not dysfunction. Bloating stems from hydration or poor forms. Opt for micronized monohydrate. Contaminants like creatinine or heavy metals plague low-quality products. Recent analyses show up to 44% tainted samples, urging third-party tested brands. Hormonally, creatine boosts testosterone via gonadal mitochondria, per limited studies. Energetically demanding tissues thrive. In women, it stabilizes mood across cycles. For pregnancy, Animal data supports safety and fetal benefits, like brain protection. Human cohorts show adjusted metabolism and lower reproductive risks with intake, but RCTs are absent. Conservative 1 to 3 grams hedges deficiencies, especially in vegetarians. Gaps highlight need for functional consultations. Segment 5. Practical integration across lifespans. Wrapping up, integrate creatine seamlessly. Mix in hot beverages for efficacy. For obesity, pair with protein and lifting to enhance ADP, curbing cravings, monitor lean mass. In youth, safe for athletes. In geriatrics, combat sarcopenia. Magnesium synergy activates phosphate transfers. Creatine's conditional essentiality empowers resilience. Apply these algorithms. Assess demands. Dose evidence-based. Follow up biometrically. This elevates care. Share your vignettes below. Until next, stay invigorated.